It is my pleasure to give a presentation here. I will talk about pest management with June spring and the strategies to reduce the drift. There are 4 parts in my presentation. The first part, the development of June spring in China. From these 2 pictures, you can see the number of Junes and applied area of June spring increased very fast in the past years. June spring had become the main pathway for pest management. About 1/3 of total areas of pest management in China were treated by June spring. Besides spring, a drone can also be used to broadcast seeds fertilizer. From the left picture, you can see seeding and fertilization area of drones also increased very fast in the past years. Then, the rationale of drone spraying in China. First, drone spraying is welcome in mountainous areas, especially complex geographic terrains. Second, drone spraying is labor-saving and low cost. I think you can understand it is labor-saving. As for the cost, it is about 10 to 20 US dollar per hectare. The third, an onboard power supply station can be established in the field so that continuous spraying is possible in the large area. This is the power supply station in the field, and this is the engine, and this is the battery. It is very convenient to recharge the batteries. This is the relationship between pesticide concentration, droplet density, and bioefficacy. You can say if a high pesticide concentration was applied, you can select a low droplet density. Therefore, low spray volume can be applied for June spring, but to ensure good coverage on leaves, small droplets are applied for June spring. This is the control of rice plant hopper. In this test, we used 3 kinds of June. This table is the information of Junes, including the nozzle and automation method. And the rice plant was sprayed 2 times with different insecticides. You can see from this graph, the control effects were more than 80% for different treatments, and there was low significant difference for different June spring treatments. This is the control spide method on citrus plants. We used 2 Junes in this test. One was from DGI and another was from Evasion. And we used 2 formulations. You can say different color, different formulation. You can say either of these 2 Junes can be used to control spide method on citrus plants. And the control effect was more than 87% within 3 days after spring. This is the control for Fusarium head blight on wheat. The first treatment is June spring, and the second treatment is June spring with adding an adjuvant. You can say adding adjuvant can increase the control effect of June spring. And the third treatment is boom spring. You can say at the same dosage, Boom spring can provide better control than drum spring. This is the control of corn borrow on corn plants. This graph is the deposit of droplets on different leaves and ears. You can see much more droplets were deposited on the upside of leaves than the lower side of leaves. You also can see droplets can reach out to ears to a degree. This because the downward airstream of drones can blow the droplets onto the ear. This table is the control effects of the treatments. You can see boom spring can provide better control than drone spring. This is the control for armyworm on corn plants. At this time, you can see the population density of fall armyworm was very high. And this column is the dosage of insecticide. You can see increasing the dosage of the insecticide did not increase the control effects. Even for boom spring, the boom spring did not provide good control. The reason, I think, is at high population density, caterpillars of fall armyworm migrate deeply into the world of corn plants. No sufficient droplets can reach out them. This is another control of fall armyworm on corn plants. At this time, you can say the population density of fall armyworm was relatively low, and drone spring can provide relative good control. Therefore, in my experience, the control effect of drone spring for the control of fall armyworm depends on the population density of fall armyworm. Then I talk about the drift. This table is the set table. This column is the diameter of droplet, and this column is the travel distance in the air of droplets. A short travel distance means the droplet cannot reach the target. Generally, there is a high risk of drift for droplets less than 100 microns. Unfortunately, for drone spring, a high proportion of droplets is less than 100 microns, particularly for rotary atomization. Therefore, drift is a challenging problem for drone spring. We tested the spray drift by spraying 2,4-D, a herbicide by June, to oilseed rape plants. The red ones is the plants, and at the same time, we collected the drift by carts. The black ones is the carts. Here are parameters of drone spring. You can see this test was conducted at two wind speeds, the low wind speed and the high wind speed. This picture is deposit of drifted droplet, and these two pictures is the affected plants. You can see the droplets of drone spring can travel about 50 meters in the air at low wind speed and about 100 meters at high wind speed. Then, how to reduce the drift of drone spring? The first strategy is to set aside a buffer zone. This table shows the travel distance for 90% of accumulative drift and the different parameters. This column is the travel distance. From this column, you can say a buffer zone at least 20 meters should be set aside for Zhuang Spring. The second strategy is to set a blocking zone. In this test, we use the component as the blocking zone. The components are about 2.5 meters high and the zone was about 10 meters wide. In this graph, the two black curves shows the deposit of droplets with the blocking zone, without blocking zone. And the red curve is the blocking effectiveness. You can see from this graph, a 10-meter blocking zone can reduce the drift by 70 to 80%. The third strategy is to add spray adjuvant. Nowadays in China, spray adjuvants are well received by farmers and Zhuang Spring operators. These two pictures are one sample for adding spray adjuvants. Relatively, adding spray adjuvant can reduce drift by 35 to 42% for Zhuang Spring, depending on the composition of adjuvants. Thank you.